All right, so this is what you should have done in your book already from in class. This is page 593. Please double check and make sure you've got it and you've got the right answers. You can pause if you need to. So there's the top half of the page. Again, just pause it if you need to. And then here is the bottom half with the factor trees. All right, so for today, we're going to go ahead and move on to the next section. So I'm just going to turn the page one time, and you guys should see this as well. We'll be multiplying powers with the same base, and the base is the big number. The objective is to multiply powers with the same base. You don't need to take notes on this, but if you want to, you could. The objective would basically be the essential question. So I'm just going to show you guys in the book, and we'll do examples out of the book. So this is on page 595. It says all of the, oh no, not that part. The essential understanding is you can use a property of exponents to multiply powers with the same base. So the big number, the base has to be the same. You can write a product of powers with the same base, such as 3 to the 4th times 3 squared, using one exponent. So look at this, 3 to the 4th times 3 squared. They both have the same base, which is 3. So in your answer, the base stays the same. And then what they did is they expanded 3 to the 4th power, 3 times itself 4 times. And then over here is 3 squared, so there's 2. And if you add them all up, there's 1, 2, 3, 4, 5, 6. That's how we get the 6. So to multiply, we just add the exponents. So if you ever see multiplication, or it might be written with parentheses around the values, you just need to remember, if you have the same base, you just add the exponents. Keep the base the same. So we're going to do some problems to practice that. I'll do a couple and then I'll leave you a few to do as well. Okay, so this is page 596. I'll write that up here so you guys can see and make sure you've got it. So you really just have to work it out. So it says, what is the expression written using each base only once? So we've got 8 to the 3rd times 8 to the 6th. We keep the base the same, and then you just add the exponents. So 3 plus 6 is 9. All right, so that is your answer, 8 to the 9th power, and you can circle it. All right, B, you notice that you have the same base, but I'm noticing we have negative exponents. So I'll go ahead and work this one out with you in the video as well. We keep the base the same, 0.5. Add together the exponents, so that'd be negative 3 plus negative 8. So you add them together and the answer stays negative. So 8 plus 3 is 11. But we learned previously that we don't want to keep negative exponents. We would do 1 over and then 0.5 to the 11th power. So when you have a negative exponent, remember to flip it, put 1 over it, and then the exponent becomes positive. Okay. And then C, I'm going to let you guys try it. Let's see what you get. Notice that there is one negative exponent and then the other two are positive. So just follow the same rule as above. So just add the exponents and keep the base the same. And then I also want you to, so you're going to do C. I want you to try, and we'll go over in class what you get. I want you to try 1, and I want you to try 2. Okay, so you've got A and B done, and then just finish the rest of that page. Okay, and then we're going to go to the next page, 597. So this is a little different, but you're still using that same rule about adding exponents. It says, when variable factors have more than one base, be careful to combine only those powers with the same base. So it's kind of like combining like terms. So on this first problem, it's 5x to the 4th times x to the 9th times 3x. So the coefficients, the 5 and the 3, they really don't have exponents. It's just a 1. Let me just show you. 5x to the 4th is like 5 to the 1st power times x to the 4th power. If you break it apart, it would be 5 times x times x times x times x. There's 4 x's, but only one 5. So that's what that means, 5x to the 4th. X to the ninth would mean 9x's, and 3x is 1, 3, and 1x. So if you want to expand it to visualize it, you could. It's all multiplication though, so I would really just multiply 5 times 3 and get 15. And then I'm going to have one base of x. I just have to add up all the exponents. So there's an x to the fourth and a ninth, and then this one is a 1. It does have a number, it's just like we don't usually write it, so x to the first power. So add them up, I'd get 10 from those two, 9 plus 1, and then 14 with that 4. Okay. All right, and I will go over, let's just do all of these ones together because they are kind of different. So for B, we have the coefficients. They're the big numbers in front, -4, 7, and 2. So it's getting a little more complicated. So I'm just going to kind of write them together. And then I have two different letters. I have a C and a D. So I'm going to look at C to the third and then C to the -2nd. I'm combining them and multiplying, but remember the way you multiply is you add the bases or add the exponents. So 3 and -2 equals 1. And then there's only one D base, so it just stays the same. And then I just want to simplify this. I would do -4 times 7 times 2. And I know that -4 times 2 is 8. 8 times 7 is 56, and it stays negative. And then when you write your answer, you don't have to write the 1 exponent. I can just write it as C, and then the D is D squared. All right, so that looks good. All right, and then C, I was noticing it's a little bit different also. I'm looking at numbers to multiply, so any coefficients. Remember, if there isn't a number, it's an invisible 1. 1 times 1 times 12. That's pretty easy. And then you do write the letters, the variables in alphabetical order. So J comes first and then K. So I'm going to see J to the second, and then one more J would make it J to the third. And then K, there's only one K base, and so that would be K to the -2nd. But I want to remind you guys, we don't leave negative exponents in your final answer. So the 12J to the third stays on the numerator, K to the -2nd will move to the denominator, and then the 2 becomes positive. So that's the final answer for that one. All right, and then I want you guys to practice. There's these two problems on page 598, just the next page. So flip over and you'll see, just so you know, if it's written with parentheses, it means the same thing as 5x to the 5th times 3y to the 6th times 3x squared. So you multiply the coefficients, multiply those, but then if you have the same base like those x's, add exponents. And x comes before y. So you can imagine your answer will be a number in front, and then x to some number, and then y to some number. Like that. That's how your answer should be. All right, and then try number 4 as well. Okay, so we'll go over those answers in class just to make sure you've got them. And then now we're going to move ahead. I'm going to skip that stuff for now. We're going to move all the way to the next lesson, lesson 10-2. So this is page 606. More multiplication properties of exponents. So the objective here is to raise a power to a power. So the exponent will be raised to another exponent. And you've probably seen this in the past in previous math classes. So here's the little box explaining it with the essential understanding. All right, so it says you can use properties of exponents to simplify a power raised to a power or a product raised to a power. You can use repeated multiplication to simplify a power raised to a power. So this is showing that x to the 5th squared means that there's 2x to the 5ths. And then we know when we multiply, we're actually adding. So that would be x to the 5 plus 5, which is also the same as 5 times 2. But either way you think of it, you end up with x to the 10th. So whenever you see an exponent raised to another exponent, it's just multiply. Remember, we just learned in the previous section, when you're multiplying and you have the two bases, add exponents. But here we're raising a power to a power, and you multiply them. And then this part explains it. If it's a to the m to the n power, you multiply. Here's with a number base instead of a letter. 5 to the 4th squared, you would do 4 times 2. The 5 stays the same. I do want you guys to notice the base is 5 the whole time. And then we get 5 to the 8th power. All right, so we're going to go ahead and try a couple problems, and then I'll let you try a couple. Okay, so I think you can probably do A and B. Okay, so I want you to try A and B. So remember, a power raised to a power, the rule is to multiply. Power raised to power, multiply powers. Keep the base the same though. So if the base is a P, it stays as a P. And I'll show you how to do C. So if it's P to the 1/2 to the 1/4, that would equal P to the 1/2 times 1/4. And that would be P to the 1/8. And one of the previous lessons, I think, showed you what to do with that. That could also be written as, it's a radical. It's not a square root in this case. It would be the 8th root of P. So whatever that bottom number is, it goes on the outside part right there. So the 8th root of P. So go ahead and give that a try for D also. It's very similar. All right, and let's see. Let's go ahead and try. We're not going to do the reasoning. It's okay, we can skip that one. And then I do want you guys to see here at the bottom. So it says simplify each expression, use positive exponents only. So I'll do number 2, and then I want you to go back and try 1. So it's x to the 3/5, but then I have to multiply times negative 1/2. So it's kind of weird because we have fraction exponents and we have one that's negative. So just remember when you multiply fractions, because we do have to multiply the powers, you multiply straight across. Remember the x stays the same the whole time through. So 3 times negative 1 is negative 3. Multiply straight across, 5 times 2 is 10. If I could reduce the fraction, I would. It is still a fraction, but I can't. So right now I'm going to remember, what does a negative exponent mean? It means I need to put 1 on top of it, basically flip it over. So 1 over x to the 3/10. But then I'm also going to write it as with the radical, just to practice that, because that is something I want you guys to know. So when I write the radical symbol, the x goes on the inside. The 3 stays with the x, but the 10 goes outside the square root. So it's x to the 3rd, and then it's the 10th root. Just remember how to do this. Don't worry too much about it. It might come up later. I just want you to know this process. Okay, so give that a try for number 1. Remember, I said that if you could reduce your fraction, you do want to reduce it. Like if it was 15 over 10, I could divide the top and bottom by 5. Or if it was 3 over 6, I could divide by 3 and get 1/2. So give number 1 a try. Let me see, I think there was one more thing. Yeah, I did want to go over just on the next page. Page 608. Oh no. Okay, page 608. It says use order of operations, which we did just review, PEMDAS, when you simplify an exponential expression. So it's an expression with exponents. So when I'm looking at A and B and C, and then down below you can see 3 and 4, I want to think what to do first. First you do the inside of parentheses, then you do exponents, then you multiply and divide from left to right. So first I look inside the parentheses, there's nothing to do, but then I would raise the power to a power. I would do exponent. So that x squared stays the same for right now, but then I'm going to do x to the 6th, and then since I have a power to a power, we multiply. So it's x to the 6 times negative 4, so that's negative 24. And when I get my final answer, I'll make sure I have positive exponents. But for right now, I'm just going to multiply these. So x squared times x to the negative 24th. I have the same base, so I actually just add the exponents. But since I have a positive and a negative, I just subtract and take the sign of the larger number. So x to the negative 22. And then when I write my final answer, I want to put 1 on top and then x to the positive 22 on the denominator. Okay, so that's basically how you do that. Let's go ahead and take a look at B. It's very similar as far as the order of operations. First, you want to do the power to the power, and then you will do the w to the negative second. So I have w to the 5 over 3 times 3. I'm going to write that out. 5 over 3 times 3 over 1. So notice that the 3's would cross cancel, and I'm just left with the w to the negative 2 stays outside. And then I have inside w to the 5th power. It'd be 5 times 1 and then 1 times 1. So it's just a 5. And then just like I did up above, I would then multiply. But when I multiply and I have the same base, you just add the exponents. That's the rule. So negative 2 plus 5 is 3. And so it just stays like that. Since it's a positive 3, we keep it. Up here it was a negative, so I had to put 1 over it. All right, and then now looking at C, it's pretty confusing looking. It's s to the negative 5th. That is raised to the 1/2 power, and then times s to the 3 over 2. So I'm going to rewrite it a little bit. S to the negative 5th to the negative 1/2, but then times s to the 3 over 2. Whoa, 3 over 2. So I do want to do this first using order of operations. You multiply the powers, so it's really just negative 5 times negative 1/2. Remember, 5 is 5 over 1. So I multiply straight across, and I would end up with negative 5 times negative 1 is 5. And then 1 times 2 is 2. So if you ever need to, write it separate on the side like scratch work. And then I'm going to multiply that times the s to the 3 over 2. And so now I'm multiplying two expressions with the same base, and so I add exponents. So just a refresher on adding fractions again. 5 over 2 plus 3 over 2. Add the numerators if you have a common denominator, which is 8 over 2. I can divide that, and it equals 4 over 1. So that would be s to the 4th power. Okay. And I do want to do number 3. Now that I'm looking at it, it has a 0. So we'll stop after. Oh, sorry, you couldn't see that the whole time. All right, so sorry, I don't know how much it was cut off. But like I was saying, it's 5 over 2 plus 3 over 2. 5 plus 3 is 8. 8 over 2, which is 4. And that's how I got s to the 4th power. Okay. And then the last one, like I said, we'll look at number 3. All right, so it's z to the 8th to the 0 power times z to the 1/2. So z to the 8th to the 0, and then times z to the 1/2. So using order of operations, you want to do your exponents first, your exponent to another exponent. So remember, we learned anything to the 0 power equals 1. So it's 1 times z to the 1/2, which is just z to the 1/2 power. And I can leave it like that, or I could write it as it's the square root of z. The 2 on the bottom goes to the outside of the square root. Either way is okay. Don't worry about doing 4. And that is it for this section. We don't need to do anything else.